Hi, I'm Derek Stiles.
And I'm Nicholas Weiner.
And I'm Tom Sludzik.
And our project was the Beverage Mixer 5000, which is an automatic drink mixing device.
And it is actually powered by an Android application that you can download if you scan this QR code. And it also works on Windows Phone as well.
Now, right here you can see our main structure, which was the final product.
And the 5 main components are the front-end web-hosted side, which is basically what the user is seeing on either their smartphone or their laptop computer. And then you got the back-end server, which is making the connections between the front-end and the back-end. And then we have the low-end code, which is actually taking those values from the user and distributing them across the GPIO pins. And then we have the circuitry, which actually powers and drives the valves, and then we have the outer structure, which houses everything.
Here we have a parts list for the circuitry to control the valves from the Raspberry Pi. Here we have each of the outputs from the Raspberry Pi going into a NPN resistor that turns on solenoids with a 5-volt bus. And then when the solenoid opens, it opens each individual solenoid up to a 24-volt bus. And then when that opens, it allows the liquid to flow.
For the structure of our product, we decided to make it primarily out of wood. And one thing we wanted was for it to be small enough to fit on your average size counter or kitchen table. And
also able to be, so you can view the liquids that are remaining in the juice maker. And this is the main microcontroller that we use, the Raspberry Pi. And it's a little $35 microcontroller that has internet, USBs, it's got an ARM processor so it can do decent at running different C++ programs. And it also has an SD card where the Linux is actually housed.
And here's just a quick steps that we went for the build process and how we went about it, and just a few steps that we went. The first major steps was just getting the microcontroller just to turn on LEDs using a code. So to do this, we made a test code to turn on each LED for a percent time to basically simulate each solenoid being open for a given amount of time.
These are just the valves that we used. There's a close-up of them. And then this is the actual relay circuit that we use to turn on and off those valves.
And right here you can see the framework for the initial structure. We just use 2x2 beams, as you can see, 4 main posts connected by braces. And we used 2 dowels to hold the liquid containers. And the back one was actually raised about 1 inch just to give us a little more flow with our gravity-fed system.
And this is after we painted it. We added a nice gold touch to it. Then we
A little bit of soldering.
And this beautiful picture is just the final product. You can see the wires coming from the Raspberry Pi, and then they're still turning on the initial LEDs that we had at the beginning, but then we also have that in conjunction with going to each of the circuits to turn on one of each of the solenoids.
Then we just got a real quick code breakdown. We go from HTML to JavaScript to PHP and then to MySQL, and then from MySQL to C++ pulls that values. This is basically, the HTML basically is just what it looks like. The Java is what facilitates the data transfer, and the PHP is what actually sends those values to the database. And then finally we have the C++ code, which Derek wrote, and it cycles through the MySQL database, pulling those values and turning on the valves. And this is our mock-up website and app. Basically what it looks like, got the sliders and the QR code and everything.
Alright, now we have a video of how the final product actually functioned.
press the button.
Now the cute drink dispenses.
And you can see the LEDs turn on with correspondence of which valves are turning on. And it was doing it with all valves turning on. It was going about like 20 or so seconds per small cup of liquid. And that's the end.
We enjoyed our presentation.
Thank you.
you.